Hello students, I am going to deliver a lecture on maxima and minima of functions of two variables in third unit of Engineering Mathematics 1. For today's lecture, we will see the working procedure of maxima and minima and how to find the maxima and minima of a function of two variables. For now, we will see what is extremum. F of a comma b is said to be an extremum value of f of xy if it is either maximum or minimum. Next one is necessary condition for a maximum or minimum. The necessary condition for a function to be maximum or minimum is fx of a comma b equal to 0 and fy of a comma b equal to 0. Here we use the following notations: dou f by dou x equal to fx and dou f by dou y equal to fy, dou square f by dou x square equal to fxx, dou square f by dou x dou y equal to fxy, dou square f by dou y square equal to fyy. Now we will see the working procedure of maxima and minima, that is the sufficient condition for a function to be maximum or minimum. If fx of a comma b equal to 0, fy of a comma b equal to 0 and fxx of a comma b equal to a, fxy of a comma b equal to b, fyy of a comma b equal to c, then f of a comma b is maximum value if ac minus b square is greater than 0 and either a is less than 0 or c is less than 0. And the second condition is f of a comma b is minimum value if ac minus b square is greater than 0 and a greater than 0 or c is greater than 0. And third condition is f of a comma b is not an extremum, that is called as saddle point, if ac minus b square is less than 0. And finally, if ac minus b square equal to 0, the test is inconclusive. For next, we will see the definition of stationary value. A function f of xy is said to be stationary at a comma b, or f of a comma b is said to be stationary value of f of xy if fx of a comma b equal to 0 and fy of a comma b equal to 0. So after solving these two equations, we get two solutions, and these two solutions are called as the stationary point. For now, we'll see some problems in for finding the extreme values of the function. The first one is find extreme values of the function f of xy equal to x cube plus y cube minus 3x minus 12y plus 20. The given function is f of x comma y equal to x cube plus y cube minus 3x minus 12y plus 20. For now, you want to calculate the extremum values of the function. That means you have to find the maximum value and minimum value of the given function. For finding maximum and minimum value, so first you have to find out the stationary point. So for finding stationary point, we have to equate fx and fy equal to 0. So for this, we need the derivatives fx, fy. So first to calculate fx of x comma y. Fx means partial differentiation of f with respect to x. So differentiate f with respect to x. And differentiation of x cube is 3x square. And differentiation of y cube, we are partially differentiating with respect to x, so other variable y is a constant, so y cube is a constant, so differentiation of y cube is equal to 0. Then minus 3x, differentiation of minus 3x is minus 3. Minus 12y, that can be treated as a constant term, so differentiation value is equal to 0. Plus 20 is a constant, so differential of 20 is equal to 0. So fx equal to 3x square minus 3. Similarly, fy of x comma y, that means partial differentiation of f with respect to y. So differentiate f with respect to y. When you are differentiating partially with respect to y, treat the variable x as a constant term. So first term x cube is a constant, so differential value is equal to 0. The second one is y cube, so differential of y cube is 3y square, and minus 3x is a constant, so its differential value is 0. Minus 12y, and differential of y is 1, so minus 12. Again 20 is a constant term, so differential of constant is 0. So fy is equal to 3y square minus 12. And denote the term fxx as a, fxy as b, and fyy as c. For fxx of xy, for fxx means that partial differentiation of fx with respect to x. So already we found that fx equal to 3x square minus 3. Then fxx means that differentiation of fx with respect to x. For 3x square, differentiation of x square is 2x. Already we have 1 3, so 6x. And minus 3 is a constant, so 0. fxy of x comma y. This means that differentiation of fy with respect to x. For differentiation of fy, 3y square minus 12. Now we are going to differentiate this equation with respect to x. There is no x term. The whole term is a constant term. So differential of fy is 0. With respect to x is 0. And c is equal to fyy. So fyy. That means that the differential of fy with respect to y. So differential of y square is 2y. So I'll take how on 3. So 6y minus 12. 12 is a constant. So differential value is 0. So 6y. But next you have to find the stationary points. For stationary points, we have to equate the term fx equal to 0 and fy equal to 0. So fx. So already we found that fx value is 3x square minus 3 equal to 0. For solving these equations, we get the values of x equal to plus or minus 1. Similarly, fy equal to 0. For this gives that the value of y is equal to plus or minus 2. Therefore, the stationary points are 1, 2, 1, minus 2, minus 1, 2 and minus 1, minus 2. The number of points depends upon the number of values of x and y we got here. Next, we have to make a tabular column where in the first row we write all the stationary points. 1, 2, 1, minus 2, minus 1, 2, minus 1, minus 2. And 1, 2 is the first point, 1, minus 2 is the second point. Then we have minus 1, 2 and minus 1, minus 2. So for each point, we have to find the values of a, b, c and ac minus b square and finally conclusion. Let us take the first point 1, 2. Substitute the values of x equal to 1 and y equal to 2 in a. Substitute the values of x equal to 1 and y equal to 2 in a. A is 6x, so we get 6. That value is greater than 0. And b is 0. C is 6y. Substitute the value of y here. So 6 into 2, 12. And then ac minus b square. A value is 6. C value is 12, so 72, minus b square value is 0, so 72. But 72 is greater than 0. So according to the conclusion, AC minus b square is greater than 0 and either A is greater than 0 or C is greater than 0. So it is a minimum point. So therefore the conclusion is a minimum point. For now coming to the next point 1, minus 2. Substitute the values of x equal to 1 and y equal to minus 2 in a. We get 6. That one is greater than 0. And b is already 0. C is equal to 6y. Replace the value of y here. So we get minus 12. And ac minus b square is minus 72. That one is less than 0. Here the condition is ac minus b square is less than 0. For this point is called as a saddle point. For next point is minus 1, 2. So replace the value of x equal to minus 1 and y equal to 2 in these conditions. We get a equal to minus 6 and b is equal to 0, c is equal to 12 and ac minus b square is minus 72. That one is also less than 0. So this point is called as a saddle point. In the same way, I have to proceed for other points. Check whether it is greater than 0 or less than 0. So based on the conditions, we have a conclusion for each point. Finally, minus 1, minus 2. The value of a is negative less than 0, b is 0 and c is minus 12. AC minus b square is greater than 0. So according to the conclusions, we have a maximum point. For this 1, minus 1, minus 2 is a maximum point and 1, 2 is a minimum point. For in the questions, they have given that find extremum value. That means you have to find maximum and minimum value. And minus 1, minus 2. will give you a maximum value. So therefore the maximum value of f of x comma y at minus 1 comma minus 2 is equal to, so replace the value of x equal to minus 1 and y equal to minus 2 in f of x comma y, we get 38. Similarly, 1 comma 2 is the minimum point and it will give the minimum value. Therefore the minimum value of f of x comma y at x equal to 1 and y equal to 2 is, we get 2. So this is the minimum value of the given problem. Thank you.